Morning, everyone. Sorry for the delay. So the title is like assessing damage probability matrices for hillside RCC buildings. Actually, Roorkee is located at we used to call it as the gateway of Himalayas because if you want to enter into Himalayas, then you have to come through uh, Roorkee. You have to enter Roorkee. That's why you used to call it as the gateway of Himalayas. And because we used to deal with lot of buildings damages assessment exactly located at Himalayan regions like Himachal, Kashmir, Jammu, and Uttarakhand. So it's like RC buildings in hill. It itself is a very big research area and very important area of research we can say to be addressed because those buildings will be subjected to a earthquake is a secondary according to us. Primary will be the landslides or debris flow during heavy rainy seasons and your no so these two is very predominant than earthquakes. So assessment of these buildings in a regular interval will keep your building alive in many catastrophic failures we can avoid when you do assessment regularly. Basically, if you go to any hill stations, the very big issue on constructing the building is transporting the materials. You can see this. We have this zone. There are 5 zones. 2, 3, 4, 5. We have removed one. Okay, in the updated codes, it is going to be increased further. It is not going to be decreased. And apart from earthquakes, as I mentioned earlier, landslides, and because of uh, or heavy rain, uh, because heavy rain is one of the very important cause for landslides and debris flow in hilly regions. It will be very difficult to address everywhere. Like you can't travel across the entire hill states, and you can't cover it up. So it's our duty to make our buildings very proper and safer during the construction design process and construction process. In any case, if you do any small mistakes, you are going to expect a huge catastrophe. Okay. So already I have mentioned like we have multiple zones and everywhere we have especially the Himalayan belt is the seismic zone belt because where our plates are merging with Eurasian plates. So that is the very most vulnerable region. That's why that's generally that area is covered under the category of zone number 5. It's a highly seismic prone zone. And you can see here how to hillside buildings vary from those on natural land. It's basically natural land. We have the surface plain, but in hills, it is not going to be a plain surface. It is going to be an inclined slope. So when you want to construct a building, you can't make the area plain. That is also not possible. So you have to make a foundation accordingly. Foundation accordingly in the sense one foundation will be of a different height, and another foundation is going to be of different height. It is going to be a inclined one. And there are a lot of stiffness variation. I will cover it up on the later slides. Like you can see this slide, a number of buildings are located at the slope, on the slope. So now, the problem with this is like it is not going to collapse by its own. During these landslides or heavy rain, when your construction obstruct the actual natural drainage, this will that water which is because of rain or heavy storm or flood that will try to travel below the ground, which will erode lot of sand particles below the buildings, and suddenly you can expect a slip plane, and that will cause sudden displacement or sudden settlement, we can say. So that will be a very major issue in our hill states, Himalayan hill states. So this is not actually a landslide. Landslide is different phenomenon. What I'm talking about is different phenomenon. So blocking drainages. Landslides are like uh, in Himalayan regions, like it's not a very solid rocky mountain. It is going to be a very youngest mountain, we can say. It's full of loose particles. One side will be loose, another side is soil profile is different, another side soil profile is different. You can see a number of fault across the hill. So probably you people know what is fault. You can see the here. That's another beauty. That we can expect lot of sudden failures, and that will cause landslide. In addition to this, we are expanding the road network. So that is also we have to make a lot of construction on the existing slopes. That will also affect your no, the profile of your hill, affect your total performance of the. You can see failures of RC buildings, which are reported in many occasions. So, what is the reason? Generally, the reasons are like first, slope instability. We should know what kind of soil mass it is. We are simply constructing the building over the slope wherever we have, and we don't even bother about the soil profile. We are simply constructing because it is going to be next to like this, like 1 over 1 over 1 over. Yeah, parallel or perpendicular. So you are like making a very huge mass construction in the hill slope, which is not advisable. We are doing it now. Second is foundation. Foundation settlement. I have already mentioned you either because of landslide or because of your water drainage. You can expect foundation settlement and lateral pressure, sliding and overturning, water infiltration. That is related to the earlier soil erosion again because of rainwater, or even you break the drainage path and overloading and the drainage issues, accessibility problems. So everything is interconnected. It is not a single, like you can't say like it is exactly because of this, exactly because of this. It is interconnected. That's why I told you land slide is not only the problem, earthquake is not only the problem. Whereas here it is, everything is combined and connected. Everything matters a lot. Drainage of your natural drainage as well as your house drainage system, everything has to be properly planned and taken to the nearby reservoir. Otherwise, this kind of disaster we can expect. So we can see the different type of failures. Like people are generally constructing homes, different phenomena there because we have a three concept. One is called moment resistant framed reinforced concrete structure, or otherwise load bearing structure. Third one we can say it's a confined masonry system. So we have a three category of buildings. When you go to hillside, hilly regions, there you can see a wonderful construction methodology which is not, uh, it can't be categorized under any one of the three which I have discussed before. So neither RCC nor load bearing, neither nor your confined masonry system. Somewhat like because the material transportation is a very important issue in your mountain based construction, material transportation. So 10 rupee item will be 100 rupees there. So everything is very costly. So they have to rely on the local construction products, materials, many other things. So people generally they will go for whatever is available. They will manage and they will do the construction part. So they have to compromise in many cases. That we can't also comply. They have to follow certain procedures. They are following and they have some certain issues. If you see in this slide clearly, columns not properly connected with beams, and columns don't have a connection with the foundation. There is no foundation at all. Foundation, the one side already I have mentioned. One side there will be a foundation. Another side they can't have a foundation. So it will be filled with. You can see the constructed with boulders and random double masonry. And your found building, one part of the building will be resting over it, and in another side it will be resting on the soil. So it is like you can see the difference. One side on the soil, another side on the we can say it's filled up soil or artificially created a foundation by using random double masonry. But none of them are properly designed, neither for the lateral pressure nor for the axial load. So it is. You can see now it is not at all designed, and people are doing by their own experience, and because they don't have space to do. And very importantly, these slopes, it is not well protected in terms of what has to be constructed along with a certain procedure to avoid these kind of slope failure during any earthquakes or during the lateral pressure due to some other landslides, water drainage source kind of. So when you do any construction in the slope, it has to be properly constructed as per our standard procedure. Detailing, design and detailing is very important. Otherwise, you can't resist the overturning moment, which we are expecting during the lateral movement. Okay, but none of the building have a proper foundation. You can see in this building. Okay. RCC, in the first image, you can see RC columns is embedded in uh, random double masonry work. Whereas in another second case is also same thing. Third is also same thing. Fourth and fifth, everything is similar to that. Now, so why we have to do this assessment? Like, we have a lot of method of assessment like seismic vulnerability index that will also tell you 0 to 1. We can say so how vulnerable your building is during earthquake. Another one we have a basic capacity index that will also talk about the capacity of the building. We have another one is Japanese seismic index and hybrid method of vulnerability index. So these everything will tell about the vulnerability of your building during earthquakes. Now we have another very interesting thing called the rapid visual screening method. See the rapid we have now NDMA National Disaster Mitigation Authority. You can see they have a rapid visual screening procedure. So anybody can use this rapid visual screening because if you have a huge amount of construction, like we can see any number of buildings in a city, it can't be assessed everywhere. You can't go every building to assess. But at the same time, if you are following the protocol given by RVS, it can be assessed because we are going to use multiple tools, including drones and GIS mapping and etc. Thing to go and take the photographs and you can see whether it is what kind of building it is. You can categorize the building whether it is RCC or it is a masonry or it is hybrid building are under the category of nowhere. So you can categorize the building and accordingly you can make the building, you can assess the building whether it is vulnerable to earthquake or not. If it is a very old, 50 years old building, it is not at all having any bands, then you can say it's vulnerable. An RCC building is there, but its column is weak and beam is strong, then we can make it as very vulnerable. So, okay. So these kind of things are categorized in this. I will brief about all these things.